So I just finished putting together Denine's video on ice cream in a baggie. And in that video, she tries to explain how salt and ice can freeze the ingredients to make ice cream, but she couldn't remember. But at that time when I explained it to her class, she says that she totally understood it, but she's not able to repeat it. So here I am making a video to explain how that process actually works. Now you have to remember there are many other factors that affect this process, but I'm giving you the very basic, simple explanation so that a elementary student, like a fourth grader, would understand. So here we go. So let's first have a little foundation talk on atoms and molecules. So we're going to look at the three basic phases of matter. I know there are four, but we're only going to talk about the three. So here, solids. And then liquid. And then gas. And inside each of those phases of matter, the molecules move. But in a solid, they move not very much. So we'll represent that with a short arrow. And in a liquid, the movements of the molecules will be a little bit more, so we'll represent that with a longer arrow. And in a gas, the movements of the molecules are more, so we will represent that with a long arrow. Okay, now let's talk about temperature. So temperature is related to these molecules moving. Okay, so let's say we want hot temperature. Hot temperature will be related to fast moving molecules. And cold temperature will be slow. Now remember, fast, we represent fast with long arrows. And slow we'll represent with short arrows. All right? Now, let's look at what's actually happening when we put ice and salt to make ice cream. So here we have a block of ice. So here's ice. And here we have water. Okay, and in the block of ice, we'll have very slow moving molecules, so they will have relatively short arrows. Not all the arrows will be the same length, some a little bit longer, but generally speaking, they are shorter. And in the water, we'll have slightly longer moving moving arrows. But not all of them will be longer. Some could be short. But generally speaking, they are longer. Okay, now when the longer arrows in the ice are moving too fast, then it actually becomes water. So let's say this one, the longer arrow actually turns into water. And that's melting, right? So that ice melts. So this longer arrow representing a faster moving molecule actually melts and becomes water. Okay, now believe it or not, in water, the shorter moving molecules or the slower moving ones, like this one here, actually freezes and becomes ice. Okay, and this process keeps repeating. So as the ice melts, the longer moving molecules, the longer arrow molecules melts and it becomes water. And then the shorter water moving molecules freezes and becomes ice. And this process keeps repeating until then all the ice completely melts. Okay, now salt actually prevents the shorter moving molecules to freeze and become ice. So it stops that. Okay, so let's think about what's happening. Here we have, let's say, two medium length moving water molecules and two shorter ones. Well, if the shorter one left and froze and became ice, that will leave two long or two medium and one short. Before we had two short and two medium. So then the temperature was a little bit shorter than the medium length. But when the short one left, then we have two mediums and one short. So the temperature actually rose up. So when shorter molecules from the water freezes and become ice, the actual temperature of the water rises just a little bit. But since salt is preventing the shorter molecule, the shorter moving molecules to freeze and become ice, the shorter ones stay. And then what happens here? As ice melts, we're ending up with more shorter molecules coming in from the melting of the ice. And then what happens? We have more shorter ones and less longer ones, so the temperature of the water actually goes down. And that going down of the temperature happens because salt is preventing the shorter molecules from going back and freezing and becoming ice. So as ice melts, we're getting a large influx of shorter molecules, making the water temperature go down. Salt is preventing the shorter molecules from combining and becoming ice again. And so the temperature of the water goes down. And that lowering of the temperature is just enough so that the ingredients for your ice cream in a baggie can freeze and become ice cream. And that's the basic elementary version explanation of how ice and salt can freeze your ingredients to make ice cream.